All right, 8.7, solving problems. 501, I'm taking questions right from your homework. On page 501, number 13, we have the following problem. Dry cleaners use a cleaning fluid that is purified by evaporation and so on. It talks about all the information here. And so what happens is that we're losing a certain number of percentage after a certain amount of time, and after a half of the original fluid remains, you have to top it up. So the question is, after how many cycles will the fluid need to be topped up? Well, we can use that compound interest formula that we had earlier to be able to pretty much answer any question of growth or decay. In this case, we have a decay problem. What we have is we need to get 50% of the solution. If we start with 100% of the solution and we drop down to 50% of the solution, or 100 liters, we drop down to 50 liters, or 100% drop down to 50%, however you want to look at it. The idea is we want to get half of the solution left. So it could be any number here, and as long as this number over here is half, we're good. All right. The next part is you have 1 plus I. Well, in this case, we're actually going down, we're decreasing by 2.1% each and every single time. So 1 minus 2.1% converted to a decimal to the power of n. N is the number of washes that are going to happen. So every time there's a wash, it drops 2.1%. All right. So we need to solve for n. So we divide both sides by 100, and you might or might not want to subtract these. Either way, this is not necessary. You could have left it as 1 minus 0.021, all to the power of n. So we have this now, and notice here that we're probably going to be taking the log, and it's true. We're going to take the log of both sides, and we do that, and we get the following. When we take the log of both sides, this is what we get. Don't forget, we need to solve for n, so we're going to take log of 0.5 divided by log of 0.979, and the result will be 33. Don't forget, you can't do half of a cycle, so it's going to be after 33 cycles, the fluid needs top-up, because at 32, it will still be more than 50%. We want to do it when it drops below 50%. So after 33 cycles, the fluid needs to be topped up. All right. Next problem. We have 2 word problems to work with. Here's the second one. Page 501, number 15. There's an equation that looks like this. Where did this come from? Well, here's the problem. A wound, initially with an area of 80 centimeters squared, heals according to the particular formula. And that's the formula I have written there. Where A is the area of the wound in square centimeters after T days of healing. After how many days will 75% of the wound be healed? So we're talking about 75% of the wound be healed. A represents the area of the wound that is still a wound. So when we're talking about 75%, that's healed. So how much is remaining to be a wound? Well, that's actually 25%. So 75%, 80 centimeters healed, 80 centimeters squared is the wound. We want to develop the equation in such a way that we'll get the right answer. Well, 80% was originally 80 centimeters squared originally started, and we're going to subtract 75% from the original. And funny enough, when I divide everything out, I end up with this equation. Look at what this equation represents. Well, it's the exponent equal to 25%. That is 25% of the wound is still left. We need to know how long that will take. Take the log of both sides and divide out the values, and we end up with T is equal to 26.1765. Now, let's say you were to calculate it down to the minute. Well, it will take 26 days. That's the first part. That's what T represented. We take the 0.1765, convert that to hours, which is what we have here, and then we take the remaining decimal that was calculated in the calculator to find out that it will take 14 minutes because we have to multiply that by 60. So, once again, we take the log and then we divide. And notice that log base 10 of 10 is 1. So when I divide out the negative 0.023, that's how I got this answer. Once I do that, I plug it in the calculator, and basically how to get to this answer, you would subtract the 26 days to leave this decimal, whatever it was in your calculator, multiply by 24 to find out how many hours, and then the remaining decimal, you would multiply that by 60 to get 14. And that's how we get 26 days, 4 hours, and 14 minutes for the wound to have healed, 75% of that wound to have healed. All right, folks, that's the end of the video. That's the end of Chapter 8. Take care. Have a great day.